Hi friends, today we are going to discuss the experiment determination of AC frequency using Melde's apparatus. For this we need the electrical vibrator and string, then a pan to add the mass. In this electrical vibrator we have a solenoid and a rod is passed inside the solenoid, and the rod is connected with a string, and the another end of the string is connected with the pan. When the electrical vibrator is turned on, a magnetic field is induced in the solenoid. Due to this, the rod is vibrated. So when rod vibrated means the string attached with the rod also vibrates. It means the string particles gets vibrated. So finally it forms a standing wave pattern. By adjusting the electrical vibrator, we can form the high amplitude stationary waves. Here I am adjusting the electrical vibrator and placing 4 numbers of loops with high amplitude. This is the tabular column for finding the square root of m by L in transverse mode. We have two different types of modes. One is transverse mode, another one is longitudinal mode. Transverse mode means the electrical vibrator kept parallel to the length of the string. Here this is the length of the rod, this is the electrical vibrator, and the electrical vibrator is kept parallel to the length of the string. So this setup is called transverse mode. So in this mode the formed stationary wave is called transverse wave. So see the tabular column. So first one, mass in pan. So we can add different masses to the pan. So initially I am adding 5 gram of mass. Next one, total load. So total load means the mass added in the pan plus mass of the pan. So at the bottom of the pan we have the total mass of the pan. See here, this is the mass of the pan, 13.07 gram. So total mass means the mass added to the pan is 5 gram plus 13.07. So now I am adding 5 gram of mass to this pan. So now the total mass is 18.07 gram. Next one, the number of loops. So for this mass we can form the maximum number of loops at a particular distance with a high amplitude. So for this mass I am forming the loops. So for this mass I am forming 5 numbers of loops, 1, 2, 3, 4, 5. So the number of loops are 5 here. So here the total mass is 18.07. The next one, length of n loops. That is the total number of loops is 5. So the total length means so the length of the string from this end to the opposite end here. So at the center of the pulley up to this center of the pulley. So this is the total length. So the length is from this rod to the center of the pulley. Okay. 137.5. So the length is 137.5, and the length of each loop means the total length divided by number of loops. So length of each loop is 137.5 divided by number of loops means we will get 27.5, and the last column is square root of m divided by L. M means total load and L means length of each loop. So square root of m by L value will be 0.4888. Similarly, we can find the square root of m by L by adding different masses like 10, 15, 20 and so on. So for different masses, we will get different square root of m by L values, and finally we will take the average for this one, means we will get a value of square root of m by L. Second mode is a longitudinal mode. So this is also the same tabular column like a transverse mode. So here also we can add different masses to find different square root of m by L value. For this mode, we can change the position of the electrical vibrator like this. That is, the electrical vibrator is kept perpendicular to the length of the string. So now we switch on the electrical vibrator, means we can form the loops with the maximum amplitude by adjusting the electrical vibrator particular number of loops in a particular distance. By adjusting the electrical vibrator for different masses, we will get a different square root of m by L values. Finally, we can take the average for this column. This is the formula for finding the frequency in two different modes. First one is transverse mode. The formula is 1 by 2 square root of m by L into square root of g by m. So square root of m by L is taken from the average of the last column of the table, and square root of g by m. So g is the acceleration due to gravity and m is the linear density. So linear density means mass per unit length. Here the mass of the string is taken as a 0.47 gram and the length is 2 meter. So by solving this, we will get the linear density value m. It is equal to 0.235 into 10 power minus 3. So by substituting all the values, we will get the frequency of AC in transverse mode. Like that, in longitudinal mode, we can find the frequency. Here the formula is square root of m by L into square root of g by m. So we can use the same square root of g by m value from this one, and this one is square root of m by L is taken from the average of the last column of the tabular column. Okay, so by using all the values, we will get the frequency of AC. For example, in transverse mode, 1 by 2 into 0.4888 into square root of g value 9.81 divided by m value 0.235 into 10 power minus 3. By simplifying this, we will get 204.315, and by simplifying all these values means we will get the frequency value of 49.93 Hz.